Hello everybody. So today's video is talking about moving averages. This is a fairly interesting concept that might actually be applicable to a lot of you going into the finance world or looking for patterns over long periods of time but don't care about the short runs. All right, so let's go ahead and get right into it. To start with, it's pretty easy to find the average of something using an integral. Because you should all know to find an average, you take all your numbers, add them together, and divide by the total number of numbers you have. Which, if you have a finite number of numbers that you are averaging, it's not too difficult. When you have an infinite number, so things are changing throughout the entire day, that gets a little bit more difficult to figure out what's going on. So in that case, you want to use integrals. So if you want to find the average of a function over a set period of time, let's say a to b, then all you have to do is integrate it from a to b and then divide by the difference. So you're still essentially adding up all of those heights, but then you're dividing it by how thick that area is. All right. So like for this function here, if we want to find its average between 0 and 20, well, we have the integral set up, and it's going from 0 to 20, and then in the front, we're going to divide it by 20. So you can quickly see through here, pretty standard integral. This comes out pretty ugly, but it comes out to this number here. All right. So that's just to finding a basic average with integrals. But often, it's more that you can't really use the individual data. One of the basic examples that the textbook will give you is talking about the stock market. If you're looking from day to day to day to day, well, it's going to be a very volatile system with lots of ups and downs. So if you're trying to get somebody to invest, they aren't going to want to invest in something that's that unpredictable. So instead, you'll want to look at something of the moving average setup. What this does is take the average over a small period of time and trace that as your function. So if you take the stock market over the last 3 days, well, average those together, and that will be what you'll be plotting. So you'll be looking at the average of your function over a set period of time, and that's going to be a lot less volatile and a lot less changing. All right. Now, to do this, it's also pretty straightforward. So you find the average of a function from over the interval x minus a to x. So x is a basic variable that you can put in. Doesn't particularly matter too much what you do. And a is the size of averaging you want to do. So if you say you want to do it over 3 days, then a would be 3. And then you put whatever x you want into it. There's a little conditions on that, but I'll get to that at the end. All right, so from this, you just integrate from x to minus a to x, and then divide by a. So if we take a look ahead and look at that same problem before, and we're letting a equal 3, we get this equation here. Now, note, you want to make sure your x value, so the x variable is a different name than the variable inside your function. So if your function is t's, x is fine. But if your function is already an x, maybe switch your variable over to t at this point. So it switches to something different so you know it has changed. You don't want to stick with the same thing again. All right, so far so good. Here, instead of putting in an actual number, you are putting in the variable x and the variable x minus 3. All right, keep in mind order does matter, and you want to make sure you have parentheses around that second half because that negative will distribute everything. It's not so much important on the front half, considering the only thing getting distributed on that is the 1/3 out in the front, but that's going on everything. All right, so when you get this all simplified down, you'll get something along the lines of this. All right, so it's still a function, but it will tell you slightly more information, but not appear as volatile. Now, like I said before, there's one stipulation on the x now. Since a is 3, your x has to be at least 3 larger than the smallest t you allowed. So if your t starts at from like 1980 and that's t equals 0, well, you can't have an average of 3 years starting in 1980 because you don't have any years except 1980s. You don't have any averages yet. You have to wait until 1983, in which case you can average up those first 3 years. All right, so it has to be at least 3 larger than the smallest of your previous variable. And not necessarily always 3, it's based on how big of an average you're doing. So for ours it was 3, it might be 5 or 10, in which case you have to make sure that X value you are using starts at 10 as opposed to the same value you had before. All right, so I want you to take a look at this exercise. So we're talking about the annual expenditure on health in the US. So it has this equation here. I want you to find the average from 1980 to now. And then I also want you to find the average expenditure over 5-year periods, and I want you to actually get the function for it. And we'll be talking about that part in class, but I will show the completion of the first half. All right, so go ahead and try it. All right, hopefully you've done well on that. And here's your initial setup, so go ahead and try and go from there. All right, hopefully you've done well on that, or you're already done. Basic integration, constants in the front don't change, exponentials themselves stay put, and then integrating, you divide by the natural log of your base. All right. All right, the next step, you plug in your values of 36 and 0. Next, you get this thing here, which, not too bad. With a little bit of work tossing your calculator, you'll get 482.545, which for your actual answer would be based on the units of your problem. All right, and we'll again go over the stuff on the front, and that will be on Monday. See you in class.